Okay, welcome to Intro to Programming for Business Majors. This is week one course. This is a course that we're going to be using Java programming language, but this is really just very much an introduction to programming and everything kind of around it. So if you're already kind of well versed in how computers work and stuff, especially this first lesson may be a bit redundant for you. But if you're new to computers, you're really not sure, this is a good way to kind of just walk into it. In this chapter, we're going to discuss introduction, why programming, computer systems, hardware and software, programming languages, what makes up a program, what is the process, and we're going to touch on object-oriented programming. Java history. Java was started in 1991 by the Green Team in Sun Microsystems, which is now Oracle. IT people like to name them weird team name colors. They do it all the time. There was a need for a programming language that could run various devices. Java was first named Oak and was developed for this purpose. Java-enabled web browser HotJava was demonstrated in 1995 at the Sun World Conference. And for those of you not old enough to remember, browsers were not free. They didn't come with a computer. You had to buy them. And a lot of times they didn't work well across different types of computers and different types of websites and stuff. So this HotJava was kind of the first one that was agnostic. And later it was incorporated into Netscape shortly after when Oracle bought Netscape. Java is cross-platform, meaning it can run on various computer operating systems. There's two types of things to think about when you talk about programs in Java and in any programming language, honestly. It is applications, and they're standalone programs that run without the aid of a web browser. So think about like Microsoft Office or anything else you've got on your computer that you download and run. They have a relaxed security model since the user runs the program locally. Applets are small applications that require the use of Java-enabled web browser to run. So they run on a web browser. So you can think of things like Google Docs, Google Sheets. They have an enhanced security model because the user goes to a web page and the applet runs itself. It's not solely located to your computer, and it can't run outside the web browser. And obviously, applets, I want to say, have got to be the biggest thing out there now because, especially with your phones, everything is kind of running on browsers. So why learn to program? Computers are a tool that can be programmed to perform many special functions, such as they can make spreadsheets, databases, word processing, games, etc. Computers are versatile because they can be programming, and computer programmers implement programs that perform these functions. So continue on to why program. Aspects of computer programming must be designed. The logical flow of instruction. All right, so I should read enough slides, not good. All right, so in a computer program, you have to tell the computer step by step what you need to do. If the old example is, tell a computer to make a peanut butter and jelly sandwich, you can't just say take bread, put peanut butter and jelly. You'd have to tell it, hey, what is bread? Where do you find it? You'd have to tell it things like open the bag, take out 2 slices, put the slices on a plate. Now take the peanut butter, unscrew the lid, So these are, and you need to have a logical flow. It's like if I try to put the knife into the peanut butter before I take the lid off, that's not going to work, and that'll break. And that's what normally happens in your programming is that you're telling it, you're not thinking clearly as a computer, you're thinking as a human, and you skip steps, and it ends up bugging out and failing. And that goes along with mathematical procedures as well, looking at the math. You want to look at the layout of programming statements, and that is more for troubleshooting later or for working with other people. You don't want just a jumbled mess. Appearance of screens, that's an entire job. UI development, UI design. The way information is presented to the user, again, that's a total design thing. It's not just stuck up there. It's like when you look at a magazine or a book, somebody didn't just put that picture in the right corner for no reason. That's a design. Somebody thought of that and looked at it and said, that's where we're going to put it. You want to think about the program's user friendliness when you develop it. Make sure that somebody can actually use the damn thing, because writing a program that nobody can use doesn't do anybody any good. And develop manuals, help systems, other forms of written documentation. look at this. Programs rarely work the first time when they're programmed. They get buggy, and then the main thing that fails and they don't work is it's mostly a syntax error type thing, or you renamed a variable you weren't supposed to, or you had a logical flow issue where you tried to have the computer do something before it did something else. Uh, Computers must perform the following on a continual basis. They have to analyze, programmers must. They analyze the program, they experiment on it, they correct and they redesign. Programming languages have strict rules known as syntax, and they must be followed carefully. Like the syntax is kind of what bites you in the rear most of the time. Computer systems consist of hardware. Computer hardware components are physical pieces of the computer. The major hardware components of the computer are the CPU, which is a little chip inside there, main memory, which is your RAM or your local memory, secondary storage devices, that could be a hard drive, an external hard drive, a cloud device, and input-output devices could be a keyboard, a microphone, a camera, a monitor, a printer, those types of things. And I do think it's funny they really don't talk about clouds here because you can see how much older this book, how the technology changed. I'm sure newer editions would hopefully talk about clouds. But here's just some pictures of some inputs. So the central processing, your main memory. This is what a desktop central processing main memory looks like. It's just in your phone, this two little dots on your chip. They're probably smaller than a dime on your board. And then you've got your input devices here. Keyboards, joysticks, webcams, external secondary storage devices. That's a hard drive. Could have external hard drives, again, cloud, speakers, monitors, and you got a printer here. Your CPU consists of two things: a control unit and arithmetic logic unit. And your instructions come in, the control unit talks to the instructions, sends it up to the arithmetic logic to do any kind of computation you have to do, and the results come out as an output. Simplistic, but again, this is an intro to programming. We don't really need to dive too hard into what the central process is doing. We've got a slide here. The CPU performs a fetch, decode, execute cycle in order to process the program information. You fetch the CPU's control unit, which we just went over, that at the bottom, down here, fetches from main memory the next instructions in the sequence of the program. So the program, like I said, we have a logical flow of instructions. Open the jar, put the knife in to get the peanut butter out. The instruction is encoded in the form of a number. The control unit decodes the instruction and generates an electrical signal. The signal is routed to the appropriate component of the computer. So could be the ALU if you have to do a computation, could just be the instruction say save this to the disk, and the signal causes the component to perform that operation. Main memory in a computer, commonly known as RAM or random access memory. This is the fast stuff. This is where everything sits, and this is when you need to make your computer faster. All the people who are into video games, they crank up all their RAM. RAM contains currently running programs and the data being used by the RAM. It is divided into units called bytes, and a byte consists of 8 bits that may be either on or off. That's why everything is byte 8. That's why when you say I got a gig really comes out to like 964 bytes or something like that. So nothing will ever be, it has to be divisible by 8 because everything is in 8 here as far as the memory goes. A bit is either on or off, 1 or 0. This is digital. That's what digital means, is 1 or 0. That's the entire phrase behind digital, because before digital you had analog electronics, which is like a wave form. Digital is either on or it's off. There is no middle ground there. Bits form a pattern that represent a character or a number. Each byte in memory is assigned a unique number known as an address, and RAM is volatile, meaning when you turn the computer off, the contents of RAM are erased. Main memory can be visualized as a column of rows and cells. Each section of memory is called a byte, and the byte has an address. A section of 2 or 4 bytes is often called a word. We have a lot in there. And this right here, this 1010, this is binary. This is the language the computers understand because it's digital. It's 1 or 0. It's on or off. All right. And these all have an address. So what happens is you store something. It knows in memory where it's stored. You can go to the address and get it. Secondary storage devices are capable of storing information for longer periods of time. They're non-volatile, meaning when you turn the computer off, they should hopefully last. And those can be disk drives, external drives, CD-ROM, solid state, USB, DVD drives. I love how outdated this is. Cloud should be on there. Input is any data the computer collects from the outside world. The data comes from devices known as input devices. It could be a keyboard, a mouse, a scanner, a digital camera, a microphone, a webcam, Output is any data the computer sends to the outside world. It goes to things called output devices, monitors, printers, other people's computers. Some devices, such as disk drives, perform input and output. That's why they're called I/O devices, input-output devices. You read from a disk drive and you write to the disk drive, so input and output. Software refers to the programs that run on a computer. There are two classifications of software: operating systems and application software. Okay. Operating systems are a set of programs that manage the computer's hardware devices and controls their processes. Most modern operating systems are multitasking. You want to think of main ones are things like, that means they can run multiple programs at once. That was not always the case. Unix, Linux, Mac OS, Windows. I want to say also I would add iOS and Android is probably I think Android is probably the biggest operating system in the world right now out there. And their Android does sit is based as a Linux operating system, but it is its own thing. Android. And like I said, there's lots of flavors. Just like you have, Mac OS 1, 2, 3. You got Windows. Linux has so many flavors. Ubuntu, Mint. There's so many out there. Fedora, Debian. The technique is called time sharing, though, for the multi-purpose. The multitasking system divides the allocation of hardware resources, the attention of the CPU among all the executing programs. And computer software, application software refers to programs that make a computer useful to the user. Application software provides more specialized type of environment for the user to work in. These include spreadsheets, word processors, accounting software, tax software, games. I'm going to pause here and we're going to pick up again with the next video.